Here we go. So there are two unique ways to write cube roots. So underline cube roots, two unique ways. One way is in radical form. There's the cube root, so the nth root is a 3. The other way is in rational exponent form. These are equivalent forms. Problems 2, 3, and 4 are very similar. Problems 2, 3, and 4 are very similar, so I'm going to go through them quickly. You start by multiplying the coefficients in front. So 2 times -6 is -12. Notice they both have that nth root of 3. You can only move forward with this type of thing when they have the same nth root. If they did not have the same nth root, we wouldn't be multiplying here. So I put the third root outside, and now I get to multiply the coefficients inside. 4 times 16 is 64, and when you have the same base and you're multiplying, you add the exponents. 7 plus 2 is 9, 6 plus 12 is 18, 1 plus 2 is 3. So look back on your charts. Find the nth root of being 3. What does 64 correspond with? 4. So this is -12 times 4. How many groups of 3 can you take out of 9? 3. How many groups of 3 out of 18? 6. How many groups of 3 out of 3? 1. Multiply your coefficients in front to get -48, a to the third, b to the sixth, c to the first. There is your final answer. Number 3. Because we both have the cube root again, we can multiply the numbers out front. 1 times 4 is 4, 2 times 3 is 6. 4 divided by 6, 4 divided by 6 reduces to 2/3. Okay, again the same nth root, I get to multiply. 108 times 2 is 216. Because you have the same nth root, we get to take the variables and add the exponents since we're multiplying. 19 plus 2 is 21. 11 plus 1 is 12. Okay, go to that chart. What does 216 match up with? So I have 2/3 times 6. And how many groups of 3 can you take out of 21? 7. How many groups of 3 out of 12? 4. And then now when you multiply here, 2 times 6 is 12. 3 times 1 is 3. 12 divided by 3 is 4. On to number 4. The number hiding out front is a 1. Okay, now this is probably new to you. What number is hiding here? We always want to say 1. If you don't see the number, you were just programmed to say 1. But with radicals, this is actually a square root, square. So there's actually a hidden nth root of 2 in this position. Okay, we have the same nth root. -3 times 1 is -3. 12 times 3 is 36. Same base, and we're multiplying, we add the exponents. 7 plus 7 is 14, and 3 plus 3 is 6. The square root of 36 is 6. And you can take 7 groups of 2 out of 14, and you can take 3 groups of 2 out of 6. -3 times 6 is -18. On your paper, you're not handing this in. I need you to write now. This is part of your task. I need you to write down your level of understanding for this. Knowing that we're trying to go through this entire unit in about a week right now, okay? So what's your level of understanding? Which problems do you need to review before your test? My goal is to get 5, 6, and 7 done next. You're going to be referring to the charts. Now, here's what you have to know. Here's what you have to know before you do 5, 6, and 7. It is not proper to leave a final answer with a radical on the bottom. If you've not done so, please rewrite this with me. This is really what this says. This is equivalent to this. But it's not proper because we have a radical on the bottom. So we need to get rid of that radical. So can you please find the table that has the nth root of 5? Please tell me what the numbers are. 1, 32. Okay, and I'm going to stop. Okay, so I want to figure out 16 times what equals one of these numbers? 16 times 2 is 32. What you cannot do is just go times 2. It has to be the same nth root. So we're going to put a radical here with the nth root of 5. Whatever we do to the bottom, we do the exact same thing to the top, so it doesn't change the original value of this expression. In doing so, we are multiplying, because we have the same nth root, 3 times 2 is 6, 16 times 2 is 32, and we know the fifth root of 32 is actually, bless you, is actually 2. This problem is done. Common mistakes in the past would be students want to go 6 divided by 2 is 3. But this has an nth root of 5. This does not have an nth root of 5. You cannot go any further with these two numbers. Moving on to number 6. Okay, let's write down, find the table with the nth roots of 4. What are the numbers?
1, 15, 81.
Okay, we'll stop. So let's rewrite this. We have nth root of 4 on top and on the bottom. So 2 times what number equals 16? 8. What I cannot just do is times 8 and times 8. You have to write them with the same nth number. So 1 times 8 is 8. 2 times 8 is 16. Now, what is the nth root of 4? It is 2. This cannot be reduced. There's your final answer. Okay, this one is a little bit trickier. So let's write down, and I'm going to do this exactly how I would do this if I were you. Okay, so I know 1 times 1 times 1 is 1, okay? And 2 times 2 times 2 is 8. I need to get past 49. 3 times 3 times 3 is 27. They don't work. 4 times 4 times 4 is 64. Okay, that's the first number. That's the first perfect cube that's past 64. But we want to be able to divide it and get a nice whole number. When you take 64 and you divide it by 49, you don't get a nice whole number. The next perfect cube is 125. Same thing, you take 125 divided by 49, and you don't get a nice whole number. Okay, so that's 5 to the third. 6 to the third is 216. 216 it also does not work. The next one is 343, is that right?
Yes.
343, it does work. It does work. So what does this tell us? We need to take 49 times 7 to get 343. So I need to take this times 7. Whatever you do to the bottom, you do to the top so that this value of the original expression does not change. 5 times 7 is 35. And 49 times 7 is 343. We know that 343, the cube root of 343 is 7. And this problem is done. Now I did have a student ask me before, does it matter if I leave my final answer in radical form or if I like to write it in rational exponent form? These are equivalent. They're the exact same thing. This is radical and this is rational. It does not matter. Okay, let's look at 8 and let's look at 9. Let's look at 8 and let's look at 9. I'm going to rewrite this at this time. So this is 7 to the x to the 1/7, x to the 1/7 times x to the 2/5 times x to the -1/10. I'm going to forget about the bottom right now. And I know that when I have the exact same, base and I'm multiplying, I'm going to add the exponents. So I'm going to type in 1/7 in parentheses plus 2/5 in parentheses plus -1/10, all in parentheses. And I get an ugly decimal. Let's turn it back into a fraction. That means that the numerator is equivalent to x to the 31 over 70. Now on the bottom I have x to the 1/5. This is in radical form. This is in rational exponent form. When you are dividing and you have the same base, we're going to subtract the exponents. Top, subtract bottom. So at this time, we're going to go 31 divided by 70. Subtract 1 divided by 5. We'll let the calculator do all of the hard work, and we'll put it back into a fraction to end up with x to the 17th over 70. Thumbs up or thumbs down with that one? Thumbs up or thumbs down? Okay, let's go to our very last one. X to the 1/7, x to the 2/9, and x to 7/11. Same thing, let's let the calculator do the hard work for us. When you're multiplying and you have the same base, you are going to add the exponents, turn it back into a fraction, and I have x 694 over 693. And I'm going to take that top one and I'm going to subtract it from 1/2. Because when you have the same base and you're dividing, you subtract. Top exponent, subtract bottom. So 694 divided by 693, subtract 1/2, turn it back into a fraction, and my final answer would be 695 divided by 1386. Does anybody else have that as an answer?